एक घंटे के लिए, खाली 1 घंटे के लिए ले लीजिए नहीं सर, मैं होटल से लूँगा, मैं स्टोर से लूँगा।
Let me know once you're able to see my screen.
Yep, I can see your screen just now.
So we are going to start inter-VLAN routing today.
Yeah.
Okay. So inter-VLAN routing basically is a process of forwarding the traffic from one VLAN to another VLAN using the router.
Yeah.
Okay.
Mm-hmm.
Basically, router will become as a gateway to forward the traffic from one VLAN to the another VLAN.
Mm-hmm.
Okay. So the port where the router is connected on the switch should be configured as a trunk.
Yeah.
To allow multiple. Okay, that's the thing you have to take care of. And then the physical interface of the router should be divided into multiple sub interfaces. Okay, so whatever the sub interfaces you create, so based on the sub interfaces you can forward the traffic of the VLAN. Each sub interface is associated with one VLAN and one subnet IP.
Mm-hmm.
Okay. So this should be called as a router on stick configuration.
Yeah.
Okay. So if someone asks, tell me what is a router on stick on an interview, you should not that what is router on stick. It's just an inter-VLAN routing which we are using. Okay.
Yeah, we're dividing the physical interface into two sub interfaces and making them to virtual interface.
Yes, correct.
Yeah.
So routing between VLANs. So routing between VLANs can be done in below ways. One is using multiple physical links called as legacy inter-VLAN routing.
Mm-hmm.
Okay. I told you, right, that I will tell you about legacy.
Mm-hmm.
So using a single link and creating a sub interface called as the router on stick, or it can be used in the multi-layer switches as well.
Correct.
Okay. So now here, this is an architecture where basically there is one switch, okay, and one switch is having two VLANs, sales VLAN, marketing VLAN, and now this fast Ethernet 0x0 is a gateway for this, and there is one more gateway with another IP address 192.168.120.250/24. Okay, so here basically you have to make it as a trunk port. Okay, then only it would be working.
Mm-hmm.
Okay, this is the this routing is when you have two multiple physical links to the same route. Okay.
Mm-hmm.
So once it's done, basically you can do the rest of the configuration on the router by configuring the sub interfaces according to the VLAN. Once that's done, the VLAN traffic would be forwarded.
Yeah, and you also have to do encapsulation that one queue in each sub interface. Yeah, if it is a sub interface, VLAN 2, then you have to do encapsulation dot one VLAN 2, and then if it's a another sub interface represents VLAN 3, then you have to do the encapsulation dot one Q3. Yeah, each VLAN represents is represented in the same number following the encapsulation dot one Q.
Yes, sir. Now the routing between VLANs using single physical link. Okay, when you have a single physical link, so that's where you just use this this kind of configuration where basically you have only one uh, one interface connected to the router from switch, and that physical link would be subdivided into sub interfaces according to your VLAN.
Yeah.
Okay.
In this case, yeah, you have to the port that is going to the ports that is going to from switch to router. You have to also do port fast.
Yeah,
Right?
that you can. No, that's not needed. Basically, port fast is something different. I'll
Yeah,
explain
the
you in
port
the
fast is
next.
like it cut down your listening and learning and go to the
Yes, correct.
forward state right away.
Depends. It depends what you wanted to use to increase your the speed, the latency.
Yeah, yeah. Because
To the switch. Yeah.
when you a switch goes from a switch itself to router port, the router do not need to be go all those listening and learning and then forwarding. That's going to be causing so much latency.
Yes.
So most of the time when you have a configuration like that, you usually do the port fast, and then also a router. A port fast is a layer two command. So router do not understand the port fast, but if you do that port fast trunk from the switch, then it will go to the forward state right away.
Yeah.
Yeah, you have to usually with the switch to switch, you never needed you do not need to use command trunk, but when it goes from switch to router and then switch port, you have to use the command trunk, port fast trunk.
Yeah. Yes. So this is basically for single physical link where we basically configured fast Ethernet 0 by 0 into two sub interfaces and assign an IP address on that. After that, basically we are using there is one more type, basically routing between VLANs using a multi-layered switch. So here basically what you do, you have configured a multi-layer, you are having a multi-layer switch. It means it has a capability of handling layer 3 capabilities. So in this, basically we just assign an IP address for any particular interface, and then that will help in uh, forwarding the VLAN traffic.
Yeah.
Okay. So what would be the command you are going to use? So first of all, you have to go into the global configuration mode, and then you have to enter into the interface mode by giving interface fast Ethernet 0 by 0 dot and the number. So the number which you're gonna use here is basically it would match to your VLAN to identify. Basically, it's being used by because it's just a standard practice, so that you can remember that if after dot, if it's a number 0 or 1, basically it represents your VLAN ID.
Yeah.
Okay. After that, the base you have to give a command encapsulation .1q, and then the VLAN ID you have to give. Once done, you can assign an IP address to that sub interface, IP address, IP you have to give, and then the subnet mask you have to give. Done. Your router on stick configuration is complete.
Yeah.
Okay. And then you just click IP routing. So IP routing, basically it will help in forwarding the VLAN traffic from router.
Yeah, IP routing command is used for multi-layer switches.
So here basically IP routing command is needed when you
you need to enable the routing.
Router stick configuration.
You need to, that enables the switch to perform as a IP protocol. The IP protocol. Yeah.
Yes. So let's say this is your basic configuration where you have configured fastnet 0 by 0.1 and fastnet 0 by 0.2, and here you are just giving an IP address. You're just also assigning an IP address to the sub interface. Both should be different. Here we are using 110.254. Here 120.254 IP address we are using it. Okay. Now how to assign. So now this is
Now,
our configuration.
is this the third octet? That is the one that goes different. The third octet.
Which one?
Over here, I see that you configure two sub interface.
Yes,
The
yes, yes.
the subnet
Yes,
mask.
there is. Yes, yes. Yeah, the subnet mask would be /24, and each one would be having a different IP address.
Yeah,
Each
but
VLAN.
it looks like the host address. The third octet represents the host address.
No, third octet is not representing the host address. Basically, that's third octet. Till third octet, it would be a network, and after that, it's a host address. So
Yeah,
that's why if you
but
see
over
here,
here, over at 254, 254 usually usually is used for a virtual IP address, mostly like when I do a router on when I do first time redundancy protocol or a gateway load balancing protocol. That is when I think the 254 comes. But I don't know.
yes, yes, we do that. Yes, 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 you are correct. Basically, we use that. It's a standard practice to use. Yeah. So now interface faster than 0 by 0. No shutdown command, exit, and then give an interface faster than 0 by 0.1. Encapsulation.1 queue, here representing 10. 10 is the VLAN ID. And then IP address 192.168.110.254. Then 255.255.255.0. Then exit. After that, interface fast Ethernet 0 by 0.2. Encapsulation.1 queue 20. 20 represents the VLAN ID. And command IP address 192.168.120.254. Subnet mask 255.255.255.0. Exit.
Now,
And then
this two IP address, there has to be in the same subnet, or it could be a different subnet?
No. That this should not be in the same subnet. It should be different. No.
Yeah,
Basically when you have a two different VLAN configuration, basically then we can change that subnet, right? We can't be using the same subnet.
You have to use the two different subnet.
Yes.
Okay.
So how you can see, by giving show IP root command, you would be able to see that what is the configuration we have done for inter-VLAN routing.
Yes.
Okay. CDP, now Cisco Discovery Protocol. Okay. So basically CDP is a Cisco proprietary protocol. CDP is by default enabled on all Cisco devices. Okay. CDP advertisements are sent through all the ports by default. Okay. And CDP advertisements are sent every 60 seconds. Okay. CDP advertisements are sent via multicast address 01:00:0C::CC::C::C::C::C. Okay. Now advantages. What is the advantage of CDP?
That is that a multicast frame, right? Is that a multicast frame address, MAC address? Because some of the multicast IP addresses starts with 224.
Yes, basically yes. That's a MAC address.
Oh, it's a MAC address. Okay.
Yes. Okay. So advantages of CDP. Basically, CDP is a layer 1 protocol. Okay, which sends the information to the
layer 1 or layer 2?
Layer 1. It's a layer 1 protocol. Why? Because basically it has the capability of monitoring the physical devices. And how it would be monitored? Basically, it would be monitored through the MAC address. And then the iOS version. Basically, carries all the information about the device. Means hardware device.
Right. Even as a point-to-point interface, CDP is active by default. If it's a HDLC encapsulation, CDP is enabled by default. Only in the frame relay it's not enabled.
Yes, correct. So once layer 1 is active, CDP sends the information to its active neighbors. It can be used for layer 1, layer 2, layer 3 troubleshooting. Okay. It means basically it will just help you in identifying the devices working properly or not. What is the logical addresses being defined? What is the host name of the device? What is the hardware platform? What is the iOS version of that, of the device? Okay, what are the interface type, interface number, on which devices it's connected? Okay, what are the number of local and remote devices are connected to the device? Okay, so these are the information which CDP advertise to the neighbors, so that they would be actively communicating between each other.
Yeah.
Okay, so what is the configuration you have to do? So basically we just do CDP run command.
Okay.
Okay, that's it. Once the CDP run command is enabled, your the CDP starts working. By default, it is already active in Cisco. But if you wanted to, means there should be some command, right, to check what is how basically CDP is enabled if it's disabled.
Yeah. So
Right.
so CDB neighbor command
Yes.
usually used for to do all this troubleshooting, to see the neighbors and
Yes. So CDP, see here, basically, the CDP is done on layer 2 switches. Okay. So here, let's say this is your switch. Basically, you have 3 routers connected to one switch, and there are 3 systems. Here also 3 systems. So from switch 1 to switch 2, basically, it's a trunk port. So once this trunk is formed from switch 1 to switch 2, you can run this CDP run command, so that all the information of this overall architecture or the topology would be shared to the neighbor.
now
Okay,
is the
and
CDB
this
run CDB enable command is an interface command, or is it, I know the CDB run, then you say you run it in the global configuration mode, but if it is interface, do you do CDB enable?
no, we don't need to assign it to the particular interface. It's just on the global configuration mode.
Okay.
Okay.
Yeah, because I can remember that I have used command enable CDP or no CDP enable command. I have used somewhere, but I cannot remember.
No CDP run command. Basically, it will disable the CDP on your
Yeah.
routers or
But
any of the devices.
but I used command enable no CDP enable or CDP enable.
See, so CDP neighbors will help you in checking the neighbor CDP neighbors. Okay, let's say if you have configured CDP run here, okay, it means the CDP is enabled on one of the switch, and on another switch CDP is not enabled. Will they be able to communicate, and it would be advertising all the details of the topology to the other switch? No, right?
No.
Until unless both are running a CDP on their interfaces or on the global configuration mode, then only they will advertise their information to each other, right?
Yeah.
So to do that, how you can check CDP? Show CDP neighbor command. You can use it to check what are the CDP neighbors for the switch, and also you can check show CDP neighbor detail.
Yeah.
Okay. Disadvantages: basically CDP can only be used in Cisco devices, and information about only directly connected neighbors can be known. Okay,
Yeah.
it means here if switch 1 and switch 2 are directly connected, right? So only this information are known. Other than that, they won't be able to share anything.
Yeah. It doesn't work in cloud.
Yeah. Link layer discovery protocol. It's same like CDP, but basically it's an open standard. Okay, and it can be configured on any of the routers, vendor routers like Juniper. Okay,
Okay.
HP might.
So it's not a Cisco proprietary.
No, it's not a Cisco proprietary.
Okay.
It's an open standard, and the standard which we are using is IEEE 802.1 AB. Okay. LLDP is a neighbor discovery protocol used by devices for advertising information about themselves to the other devices on the network, like CDP does. Okay, by default, it is disabled on Cisco devices. We need to manually enable it. LLDP advertisements are sent every 30 seconds. whereas CDP send the advertisement every 60 seconds.
Yeah.
So LLDP is more convergence.
Yeah, but you can
Let's see.
configure the Cisco or CDP to converge in 30 seconds. Can you? That was the
Uh,
that's the default configuration, 60 seconds.
yes, yes. So
Mhm.
basically that we can do it, but mostly we avoid doing that.
Okay.
Okay.
If you have a Juniper on one side and you have a Cisco on another side, Cisco is 60 seconds, Juniper is 30 seconds. Then is that going to be a convergence here?
If they one side it's a Cisco and one side it's a Juniper, basically CDP won't work.
Okay. No, I'm
Okay.
sorry. LLDP. Sorry, LLDP.
Yes, LLDP.
Okay.
So LLDP have the convergence as 30 seconds only, and that is the max you can set. And 30 seconds is far more convergence, because if you just remove the convergence, reduce the convergence time to, let's say, 10 or 15 seconds, basically how much bandwidth it will consume to share those details,
Yeah.
right?
Yeah.
So that would become as a drawback instead of becoming a convergent.
Yeah.
Yeah. So LLDP advertisements are sent via multicast address 01:80.C2:00:00:00:0E. Okay. And what is the command you are going to use? It is LLDP run, same as CDP. And what is the command for verification? You have to give show LLDP neighbors and show LLDP neighbor details. Okay. Now we move to spanning tree protocol.
Yeah.
Okay. So basically, do you know why we need spanning tree protocol?
Yeah, because you need a spanning tree protocol because you want to avoid the routing loop. You prevent the loop because
Yes, correct.
you have a
So
spanning
basically,
tree
prevent the loop.
configure and a spanning tree select root bridge, and root bridge is the one
Yeah.
send all the BPD bridge protocol data units. And that's like same as a designated routers in the layer 3 and the layer 2 use root bridge, and the root bridge concept is applied in spanning tree.
Okay.
So
Yeah, that's
basically
correct. So
you avoid the routing loops.
Yes, to avoid the routing loops. Yes, correct.
Yeah.
So basically, spanning tree protocol is used when basically you have a redundant links configured on the switch. Okay, if basically there are two redundant paths to reach out to any particular destination from switch, basically that time what happens? Basically, it will create the loops, right?
Yeah.
Okay. So at that time, basically, only one link would be considered as an active, and other would be in the
blocked
state.
Yeah, because you have switch port and you have a designated port. Designated port and a root port. Root port and designated port. They are the one only started to send the BPDU. BPDU flows to those two ports and make one port block port. So
yes, correct.
This way you can force that information to flow in one direction rather than in a reverse direction.
Yes. So when you have a redundant topologies, so basically what will happen? There would be a multiple frames, multiple MAC address table entries, and there would be a broadcast terms. Whenever there is a communication going on, there would be a broadcast terms for the frames. So that's why basically it would create a loop, layer 2 loops. So that's where basically your STP come into the picture.
Yeah.
Okay. Let's say this is one of your diagram. Here you have one link to this switch and this switch, and switch 3 as well. You are interconnected with each other. Now this links basically what will happen when the traffic is flowing, okay, and the frames being sent to the another, and the data being sent to the another switches. So basically that would be forwarded to each of the switches.
Mhm.
Okay, at the same time, if some other switch wanted to communicate and send their frames, basically what will happen, it would create a broadcast storm,
Yeah.
right? And it would create a loop in such a way that those switches won't be able to communicate between each other,
Yeah.
right?
Mhm.
So to remove that or avoid that switching loops, basically we use spanning tree protocol.
Yeah.
Okay, spanning tree protocol is used in switch networks to avoid switching loops. Okay,
Yeah.
it uses spanning tree algorithm,
Yeah.
and in this, basically STP blocks the redundant path that could cause a loop.
Yeah.
So let's say here you have the three links which is connected between these three switches,
Yeah.
and here if you see there are having two paths to reach out to any particular destination,
Yeah.
right? Particular switch. So switch what it STP what is that it will block the redundant path,
Yeah.
and it will there would be only single path for that time, and then the frames would be or the data would be sent or received.
Yeah, when it's a
Okay.
block, it doesn't mean that it does not receive BPDU. It still keep receiving BPDU, but it's just that BPDU as non-active in that port.
Yes, correct.
Because again, if they don't receive the bridge protocol unit, that block straight will unblock and will become a designated port itself. And then when you have a designated port, it will start to forward the BPDU or receive it'll keep starting for the BPDU, and then that'll cause the routing loop, bridge loop also.
Yes.
Yeah.
So STP
So
is
a
an
lot of
open.
time, BPDUs come. You are a block port. Your opposite side is a designated port. So BPDUs come in from both designated port. Your interface up and up. BPDUs come in, and all of a sudden, because of some problem, BPDUs stop coming, and it will wait for 30 seconds before it it turns into a this blocking port turns into a designated port, and then
Yeah.
the whole direction changes. The BPD flow change direction is totally become change, and then that causes the physical or logical topology to go totally haywire
Yes.
and
Correct.
totally become desynchronized. So that's why you need to intervene in that circumstances to keep your topology in sync. So
Yeah.
that is when you start to manipulate all those BPDU guard command or BPDU filter or
Yes. Correct. Yes. Yes. We do
and
that.
many times you use port cost. You use cost to influence them.
Basically, port fast is used when you basically just wanted to reduce the latency for each
Yeah,
frames or the data which is being transferred.
yeah.
Okay.
Mhm. Also, you can use the forward timer delay. Forward timer delay also reduces your because if it goes down and then it comes back again, then use the forward timer delay so that you forward it right away instead of waiting and listening and running and avoid latency.
Yeah. So basically, STP is an open standard, and
Yeah,
the standard which we use is IEEE 802.1D. Okay.
yeah,
So roots STP terminology root switch. Basically, the switch with the best or the lowest switch ID would become as a root switch. Out of all the switches in the network, only one switch would be elected as a root switch.
yeah. When
Okay,
you have a
and root switch would become as a focal point of that network.
yeah, glue switch is the lowest cost to root bridge.
Yes,
That is
yes,
considered
correct.
to be root switch. Yeah, and
Yes, correct.
then
Switch ID. Each switch has a unique identifier called a bridge ID or the switch ID.
yeah,
Okay, bridge ID is obtained by priority was the MAC address of that switch.
uh-huh.
Default priority for switch is basically 32768.
Okay.
Okay,
Yeah.
non-root
Also,
switch.
priority. You have the two switches. One has a priority number low. Other has a priority number high. So BPDU start to
Yeah.
flow from lower priority number. This is how you
Yes,
also manipulate your flow of BPDU in a topology.
yes, correct. Non-root switch. All other switches other than root switch is called non-root switches. I'll just explain you in the next slide. Okay.
Yeah.
BPDU. So basically, switches exchange the information using bridge protocol data units. Okay. It contains all the information that help to switch to determine the topology. Okay. BPDUs are sent every 2 seconds to the to the switches. Now, what are the STP port states? So basically, there are 4 states: blocking state, listening state, learning state, forwarding state. Okay. So according to this state, what are the functions it do? Okay. Forward frames, learn MAC addresses, BPDU, and duration. Okay. So blocking, basically, it will not forward any frames. It will not learn any MAC address, but it receives the BPDU.
Yeah.
Okay. And the duration would be 20 seconds. Okay. Listening state also, basically, it will not forward any frames. It will not learn any MAC address, but it can send, receive BPDU.
Yeah.
And the duration time would be 15 seconds.
Yeah.
Learning state, basically, it will not forward any frames. It will learn the MAC address. It can send, receive BPDU, and the duration time would be 15 seconds.
Yeah.
Okay. Forwarding. For forwarding, basically, it forwards the frame to the next switch, and it will learn a MAC address, and it can send, receive the BPDU, and the duration time is also the same, 15 seconds. Okay.
Yeah.
Now, this is your, let's say this is one of your architecture, switch A, switch B, switch C. Okay. In this, basically, each of the switch sends their BPDU to their interconnected switches. Okay. In that BPDU, basically, it have switch ID, root ID, and BPDU root ID. Okay. So once that is done, based on the switch ID, which is the lowest priority one, would be considered as a root switch.
Yeah.
Okay. So here, if you see the switch ID starting from B, it's 327.0001.0000.0002. Here 02, here 03, and here it's 01. Okay. So once this has been identified that the lowest priority is switch A, okay, basically it
lowest
considers
priority, right?
that yes, I'm having the lowest switch ID, so I will become a root switch. Okay. And then the root ID would be considered as 32768.0000.0000.0001. Okay.
So
And
the,
this
so
is
the
forwarded
lowest root
to
ID,
all.
lowest root ID is the one that determines the root bridge, correct? Initially.
Yes, correct. Yes.
But yeah, we can change it to the spanning tree VLAN 1 or 2 root primary using this command. We can change on our own.
Yes, we can change it. We can
Yeah.
change it. It depends. Means which switch you wanted to make as a root switch.
Yeah. And then since these are all trunk port, it's if you make one switches to root bridge, it affects all the VLANs. So you specifically mention if you want to use this switch selectively for a root bridge for one VLAN, is specifically mentioned that VLAN, like spanning tree VLAN 2 root primary. This command.
Yes.
Or spanning tree VLAN 3 root primary.
Yes, you can do it.
Yeah.
You can manually do the configuration as well. It depends. Okay. If you wanted to use the default one, or just you can manually wanted to make one switch as a root switch.
Yep.
Okay. So once the election is complete, okay, it would select as it would router. I mean, switch A will consider it as a root switch, and Other two switches would be a non-root switch.
Yeah.
Okay. So terminology in STP, root port. So every non-root switch must have a root port.
Yeah. So you understand when you see a topology and you see a switch that has all designated port, but it doesn't have any root port. So if you see the topology that way, then you immediately find out that that's the root bridge. You even do not need by looking at the topology, you can find out that that is the root bridge because it has all the designated port and no root port. Because when you don't have a root port, when you have a root bridge, you don't have any root port.
Yes. So basically, when root port is used or been considered when a switch is connected to the root switch.
Yeah.
Or the root, you can say. Okay.
Root port is a port of a switch.
So let's
that
say
is the
in this
closest to the root bridge.
Yes. So in this diagram, if you see route switch C is connected to switch A, which is a root switch. Okay. So here fast Ethernet 0/23 would be considered as a root port.
Yeah, because this port is closest to the root bridge.
Yes. And there would be only one port per switch would be considered as a root port.
Yeah.
Okay. And all root ports would be in the forward state always. Okay. And root switch port is the closest to the root switch.
Yeah.
Okay. The cost with the least cost, the port with the least cost, and the port with the lowest neighbor switch ID, lowest physical port number would be considered as a root port.
Yeah.
Okay. So now the cost, how you can identify the cost. So Ethernet, the cost would be 100. Fast Ethernet, the cost would be 19. Gigabit Ethernet, cost would be 4. 10 gigabit Ethernet, cost would be 2.
Yeah.
Okay. Now the designated port. So designated port is elected based on for each segment there would be a designated port.
Yeah.
Okay. So the designated port would also be in forwarding state. The port with the least cost. Okay. So here, if you see, which would be considered as a designated port, can you tell me? Here the cost is 19, 19, and 19.
Yeah. So the least cost, you said that this one and this one. What was your question? Can you repeat the question?
I was saying, so there would be a designated port as well, right? Okay. So designated port basically always be in the forwarding state.
Yeah.
And the port with the least cost would be considered as a designated port. And the port with the lowest neighbor switch ID.
Yeah.
Okay. Would be also considered as a designated port.
Yeah. Lowest, so when you see that all the costs are same, then you go to the port ID with the lower port ID. So over here we can see that they're all costs are same. So we have to find out which port ID is the lower one. So this is the higher, this is the lower. So this between these two, this is going to be the designated port.
Yes.
With the 0, 0, 0, 2. And since 0, 3 is higher, it's not going to be designated port.
Yeah. So lowest physical port number. All ports would be trunk port on the root bridge are designated ports.
Yeah.
Okay. So for you example, this from from switch A means from the switch root switch, fast is 0/23 and fast and 0/24 is selected as a designated port. Okay. And also this B as well. Okay. In B, if you see, there is faster than 0/23. Why? Because the switch ID would be a switch ID between these two. The lowest is switch B.
Yeah.
And same goes with,
because the problem is you have the cost.
A to switch B.
Yeah.
Okay.
Lowest cost, and if the lowest cost is all same, then lowest ID, right?
Yes, lowest ID. Yeah. Non-designated ports, the ports that are neither root ports nor the designated ports, these ports are blocked by STP. Okay, that is called as a non-designated port. So for you, basically, the non-designated port is this switch C's faster than 0/24 is non-designated.
Block port
Okay.
or block port.
Neither a root port or neither it's a designated port.
Yeah.
Yeah. So root port selection is also done. How you can configure it? See, this is how you can configure it and make it as a primary and secondary.
Yeah.
Okay.
That's what I said.
So here's spanning tree, VLAN 1, root.
Primary.
If you wanted to make it as a primary or secondary, it depends. Okay, which VLAN you wanted to make it as a root. Okay, so once this done, your root switch will be configured on STP. Okay, and if you see an STP configuration like this, you are using two different ports connecting to the other switches as well.
So it's basically
here,
an ether channel here. This is an ether channel.
Yes, it's not an ether channel, but we basically configure two different trunks.
Okay.
Okay. Ether channel basically combines your ports.
Two ports
into one logical.
One physical port.
Yes.
And this way.
Physical port will be converted into one logical port.
Yeah, two physical port is converted into one logical port. Yeah.
Yes. Okay. So here, see, switch 1 would be having spanning tree VLAN 1 route primary, and then switch spanning tree VLAN 1 route secondary. So here basically we are making switch 1 as a primary root switch.
Oh, okay. Yeah.
Okay.
Because of the project that I did, I had to configure that those two trunks link as the ether channel.
Okay.
Yeah.
Yes, that can be done. That is also there. Means you can only do the ether channel can be made between two trunk ports only. It's not on the normal port. You can't configure ether channel on the normal ports.
It has to be trunk port.
Yeah. So if you wanted to check the STP configuration, then you can give show spanning tree. Then you would be able to see the details of the spanning tree configured on your switches. Okay. Types of spanning tree protocols. So basically, we have 6 spanning tree protocols. One is common spanning tree protocol, which is CST, which is an open standard, and it's an standard is IEEE 802.1D. In this, basically, one spanning tree instances run on the entire network, regardless of how many VLANs are there. Okay. Next is per VLAN spanning tree. It means basically it's a Cisco proprietary, and this basically we use spanning tree for each VLAN configured on the network. Okay. It means basically on the common VLAN, spanning tree, basically entire switch would be having only one spanning tree instance.
Okay.
Right. But in PVST, basically we have a spanning tree instance based on the VLANs. How many VLANs you have, so how that many spanning tree instances we can configure.
Okay.
Okay. RSTP, open standard IEEE 802.1W. It is an enhanced version of STP. So basically, it adds the roles to the ports and enhances the BPDU exchanges. It means it would reduce the latency taken to forward the BPDU exchange.
Yeah.
Okay. Fourth is rapid PVST. Basically, it's a Cisco enhancement of RSTP with using PVST. It means this RSTP is being used with this per VLAN spanning tree. Okay, it means this RSTP would be using the features of PVST. Basically, it means you can use multiple RSTP instances based on the VLAN.
Okay.
Okay. Multiple spanning tree. It's an open standard, and the standard is IEEE 802.1S. it maps multiple VLANs to the same spanning tree instance. Okay. Now, so comparison of spanning tree protocols. So these are the protocols we have and standards we are using here. Resources needed, convergence, number of STP instances you have. Okay. So normal STP, basically you have standard 802.1D. Resources needed is low, convergence rate is slow, and number of instances you have per switch basically is 1.
Now,
Okay.
how often this variant type of STP are used in the corporate environment?
So basically in corporate environment, if let's say if there is a small network, okay, there basically we use STP. But for larger networks, if you are having more than 2,000 or 3,000 pieces connected, okay, in a network, then basically we use this based on this rapid PVST we basically use, and also we can use PVST. Okay, MST would be used. Okay, so these are the protocols we use. But for in my project, basically they used RSTP.
Okay.
Yeah.
STP and RSTP, right?
Yes.
Okay.
So PVST, it's a Cisco standard. Resources needed is high, convergence rate is slow. Basically, PVST is for 1 per VLAN.
Okay.
Okay. RSTP, its standard is 802.1W. Resources needed medium, convergence rate is fast, and number of STP instances are only 1 per switch. Okay. Rapid PVST plus, basically it's a Cisco proprietary. Resources needed is very high, convergence rate is very fast, and basically one STP instances per VLAN.
Yeah.
Okay. MST 802.1S standard. Its resources needed would be medium or it can be high. The convergence rate would be fast, and 1 for multiple VLAN. Means you can configure one instance for multiple VLANs. Let's say if you are having 10 VLANs, for 5 VLANs, basically configured one instance, and for other 5 you have configured another STP instance.
Wow, this Cisco itself is a huge, I've been studying these things. I figured it out. I still have so much more to learn. It's a huge.
Yeah,
it's amazing.
It's huge. Yeah.
When you learn, it's never ending. It's just never ending.
Yes, it's really never ending. When you learn in when you have CCNP switching, if you are learning, that time basically you would be having a descriptive knowledge on these protocols as well.
Yeah.
Basically,
this is why the CCNP divided into many parts. CCNP switches, CCNP routers.
Yes, because it's very vast. Yeah. The topics are very vast in CCNP.
Yeah.
So disadvantages of STP. So spanning tree protocol running by default on all the ports. That's by default in Cisco. So spanning tree protocol makes each port wait up to 50 seconds before data is being sent to the port. Okay. So the convergence rate is quite slow.
No, but you can spend each port wait. You don't have to be wait. You can do the forward timer delay command, and then within the forward timer delay, you can make it 8 seconds. Once the 8 seconds, you go to the debug spanning tree events. You can see that timestamp. It went to the learning. It went to the
even though if you change it to the lesser delay time, then also there would be a problem, because we can't use this STP for your large networks. If there is any huge applications running on your network, then there would be not a possibility of reducing that much of delay. Basically 8 seconds is also very much delay, right?
Yeah.
So that's why basically we use MST or RSTP.
Oh, okay.
Basically, it
For
reduces your
faster convergence.
latency by 10 times.
Mhm.
Okay.
Mhm.
So the delay in turn caused problems with some applications and protocols.
Mhm.
Okay. To solve the above issue, port fast can be implemented on Cisco switches.
Yeah, port fast. The port fast command is a very
Yes. STP will be configured with post fast will
yeah.
resolve this delay problem.
Yeah, yeah. If it's as I mentioned earlier at the lecture, that if coming from a switch to router, the switch always has to be configured port fast, and he
Yes.
also has to use the command trunk, because port fast is active on usually access links. But if you want to
Yeah.
use that port fast in trunk link, you have to uh, use that extra command trunk.
Yeah. So we can wind up the class here today. We'll start the port fast tomorrow.
But we're going to do port fast tomorrow again. Yeah. Okay.
Yeah. Okay.
All right.
So we can done for the day.
What we're going to have after port fast? Are we going to be doing port fast and what?
After port first configuration, we have a BPUD guard, and then we have Ether channel. After Ether channel, we have uh, HSRP configuration, then port security. Okay. And then we have switch port analyzer. Will tell you how basically is being used, and we have SNMP configuration as well.
Okay.
ACLs, like I told you.
Mhm.
So we basically cover all the things of CCNA.
Okay.
Okay. We have HSRP configuration. We will just have a brief touch on VPNs as well.
Okay.
VPN connections. We basically I'll help you in understanding GRE configurations.
Mhm.
Okay.
All right.
Yeah.
Now,
then.
you're specialized on Azure, but you're not, have you ever worked with AWS? You have not worked with AWS?
I have never worked, but I have basic knowledge on that.
Because I did that AWS cloud architecture, but but it's only in the network section, not on every area, you know, not the DBA,
Okay.
not the apps, just only the network. So
Yeah.
I've been thinking, I was trying to update my resume, but I've been thinking about reviewing a little bit about AWS that I did, and then put that in my resume, so that, you know, it becomes more sellable, you know.
Okay. If you want, I can help you in learning Azure.
Which one? Azure?
Azure, yeah.
Okay, but that's I just wanted to do the things that I already learned, you know. Azure, that's going to be a totally new thing, isn't it? Totally new thing.
No, it's not too many new things. Basically, it's quite similar to Azure, but AWS. But the thing is, there would be different configurations we do. That's it.
Oh, okay. But when we do Azure, are we going to be doing a comparison between AWS and Azure?
Basically, I can help you. That means what are the differences we have, and what are the similarities we have in AWS and Azure that we can do.
Okay. Now, to learn Azure, do I have to go subscribe to any portal so that, you know, I can actually apply, or just theoretical knowledge?
No. Not theoretical knowledge. I will explain you through portal, Azure portal.
Like we're gonna go Microsoft, and then
yes, Microsoft. We will take Microsoft Azure's subscription, and then we'll help you in configuration of that whole cloud.
Now, that subscription cost, I have to bear that cost, right?
Basically, for you, for 1 year, basically it would be free. if you are taking for the first time,
Uh-huh.
so it will be free for you for 1 year, and
Oh, let's
they
go.
will
Yeah, let's do
give
it. Then as soon as we
uh,
finish this one, we're gonna go jump into the Azure.
yes, they would give you $200 free credit.
Okay, for one.
Okay, for
What,
1 year.
what are the limitations? Is this just we are gonna be able to just do things only just learning? Anything that we need to
Yes, yes.
go
No,
and
no, no.
learn, right?
We'll just do learning.
Okay.
Yeah.
Okay. It's not for commercial purposes, right?
No, no, no.
No commercial use.
Not commercial.
Okay. Because I know that if
For
you do,
commercial, basically you have to upgrade your subscription from free subscription to your pay as you go subscription.
okay. Yeah, because Azure is
Okay.
becoming very popular now. You know,
Yes, yes, yes.
because
There
it
are
used to be AWS has their most the market share, but now Azure is taking a big chunk of it in the United States.
yes. Basically, they are providing much more better features than AWS.
Okay.
Yeah.
So
They
when
are
we do,
upgrading themselves, and they're adding much more different features and products on that Azure cloud.
okay. And what way Azure is different than Active Directory domain services?
See, Active Directory domain services basically is for your identifying. Means if you wanted to have your permissions, okay, if you
No,
wanted to restrict.
no. What I mean is like Windows Server. What way it is very
Uh-huh.
different than Windows Server?
See, Azure basically is a cloud in
Okay.
which basically you have your servers. So it can be any servers. It can be a Linux servers. It can be a Windows servers
Okay.
based on your requirement.
Hmm.
Okay,
Okay. All right.
that's and basically Azure is used for hosting your applications,
Okay.
right?
Yeah.
And it has the capability of forming the network connectivity as well. Means if you wanted to have a private network to access those applications on the servers,
Okay.
so they provide VPN connections, they provide MPLS connections.
Oh, okay.
Okay.
Now to go this learn Azure, do I have to go through Click ID or I have to go I have to contact the Click ID, right?
It depends. Means if you want the direct classes for Azure, then I can provide you.
Okay.
So you don't have to go to Click IT. I will help you in that part.
Mm-hmm.
Okay. For if you wanted to go through that, that is also fine. No problem.
Yeah, because what happened is that I want to go through that because I need the references, you know,
Yeah.
because you are located in overseas, so I'm not sure how
Yeah.
much it is gonna be. You're gonna be helping is gonna be helping me to provide the references. Because the whole purpose I'm enrolled with this program is to get that references, you know.
Yeah. Yeah, that's fine. You can go through Click IT. No problem.
Okay.
Yeah. Okay. Bye-bye.
All right.
Yeah. Bye.